Okay, hello everyone. It looks like we are live, and I'm so happy to see so many people here right now. I'm Aleksander VOLOCHNEV, developer advocate at DataStax, development relations team, and here is Erick RAMIREZ with me. Hi, Erick.
Hello, everyone. Hi, Alex. I'm pretty excited to be here today. So it looks like we're going to have lots of attendees, and let's have some fun.
Yeah, that's incredible. I want to say what we have people from all around the world and all the attendees I see from many different countries. Thank you guys and ladies for writing in the chat. Where are you from? Which country are you from? It's very interesting to see how the community grows and how many different developers from Europe, Asia, Africa, America, and so on. We have so many people. In our case, we are completely distributed. So I'm in Germany at this moment, and Erick, you are in Australia, correct?
Yes, Melbourne, Australia. That's right.
That's incredible. So, welcome to the Cassandra Workshop series. I'm really happy to see you here. It's the biggest course we are doing so far, and that's incredible to see how many people are interested in the course. If you watch the screen, you see like we have now almost 9,000 registrations. That's as much people as you see on the screen, and that's simply incredible. So you want to be stronger in the databases and know how to handle your data more and more, and that's great. So today with you, not only the two guys you are seeing at the screen, me and Erick, but also all the developer relations team. Cedric Lunden, Patrick McFadden, David, and Erick and Bethany, and so many people working together to deliver this course, and they all happy to answer your questions in the chat. Now about answering questions. During the workshop, we recommend you to ask the questions at the Discord. I kindly ask our team to publish the link to Discord in the chat. Discord is the main server for us to communicate. You can ask questions at the YouTube, but as soon as workshop is over, your questions will be gone, and we will not be able to answer questions because YouTube closes the chat session. And in the Discord, we can communicate in any moment as we have people from all around the world. So for today, speakers, me, Aleksander VOLOCHNEV, and Erick RAMIREZ, but we also have with us Jack Fryer is an incredible community manager which organizes all the events like this. Thanks, Jack. Bettina Swinnerton is our community engineer, and she's answering your questions mostly at Discord. And Cedric Lunden, the director of developer advocacy, and he answers your questions at YouTube. And I hope we have some more guys from DataStax to help us with it because we have a lot of attendees. So it's a workshop series, so we can say it as a course. And during the first part of the course, we discuss how to build cloud-native applications using Cassandra. First week, so this week and this workshop, it's getting started with Cassandra. What is it, how it works, why do you may need that, why do you will love it, and so on and so forth. Next week, it's data modeling for Apache Cassandra. It's a very important workshop because your application cannot be effective with the data model done wrong. Apache Cassandra offers so many coolest features, but if you do your data model wrong, you can ruin everything. So stay tuned, see you next week for data model. Then, week 3, that's application development, backend services, and CRUD, so create, read, update, delete, basics of application development for Cassandra. And week 4 is the upgrade, application development, but to speak more about microservices and REST API. Then, second part, which may be more interesting for the ops guys, it's about to test, deploy, and monitor your clusters and applications. So week 5, going to be operating your Cassandra clusters. Week 6, running Cassandra performance tests How do you evaluate your model? How you are successful with Cassandra? Again, data model is everything. Week 7, testing your deployments and troubleshooting. And week 8, deploying Cassandra with Kubernetes. Now, you know, like cloud is everything. And if you're in the cloud, mostly probably you're going to use Kubernetes, at least very often. And people ask us more and more how to deploy Cassandra with Kubernetes. So we say a word about that.
That's a lot of stuff, Alex, to cover.
Yeah, but okay, we have like 8 weeks, 2 hours of content every week. And when you do your job. So how it works in general. First, you attend one of the 2 live streamed workshop. So some of you maybe know, yesterday was the first run of this workshop, but it was more for the America's timeline, time zone, and so on. And this one is more friendly to Europe, India, and so on. So you can choose every week, Wednesday or Thursday, which time zone suits you better. And
right, because there's actually quite a few questions about that. So each week, there's 2 sessions. They're the same content for those sessions scheduled for that week, and you only have to attend one of the sessions.
Yep, and then some of the homework, and we wait you for the next week. So a little bit of the materials we are going to work with today, and not only today, but the upcoming workshops as well. Courses. DataStax developers at YouTube and on Twitch, whatever you prefer. We stream at both YouTube and Twitch. But YouTube is the main channel for us, so don't expect your questions answered at Twitch. That's the main part at the YouTube. Now, for the questions, again, I recommend to use Discord. You can ask at the YouTube, but it's better to log in at Discord. It really works much better. Then, for us to ask questions to you, we use menti.com. Menti is a Mentimeter application just to run quizzes. So we will do some quizzes today, and the winners will get some swag. So there will be a little competition. We like it. Then, runtime. For this and few next workshops, we are using astra.datastax.com. What is it? Astra is basically a Cassandra as a service. So to make workshop smooth, we don't want you to install all the things at your laptops. Sometimes it's quite like a lot of things to install. So we try to use as much deployed already in the cloud services as possible. In this case, Astra is a Cassandra as a service. All the exercises we are doing with here, you can do on your own self-deployed Cassandra, but we suggest to use Astra just because it's easier. There is a free tier available, no credit cards. You can simply go and get your Cassandra for free, available forever. Materials. All the things are stored you may need for these workshops, stored at github.com, DataStax Academy /Cassandra Workshop Series. I hope we already have link at the YouTube, or we'll have very soon. Now,
yeah, so someone will be posting those links.
Yeah. And starting week 3, we will work with some coding exercises live, but also in the cloud. So you can do exercises using your own IDE, but we also have cloud infra for you to do all the things with Gitbot, which is very great. After the live streamed workshops, with all of your questions, ask it at the Discord or at the community.datastax.com. You do homework, and if you need any help, community.datastax.com. It's a forum where we discuss all the questions like how to create efficient data model, what's the problem with my application, why it doesn't work, and so on and so forth. Community is kind of a Stack Overflow for Cassandra or DataStax enterprise related questions. Then, trainings you may need to take. The academy.datastacks.com. There are free courses available for everyone, and those are really great, high quality content. I do recommend for everyone who wants to get deeper. Yeah.
So just really quickly, Alex, so there's a few questions already coming up that keeps repeating all the time. So the course is, today's session will take about 2 hours. I know that there's a lot of people that are asking questions about things that we will cover, because I think, you know, there's a few people that want help with problems that they're experiencing with their production clusters. If you can, just pay attention to the course for now. And there's also people asking about the link to the quizzes and stuff. We will have that on the screen when we're ready to do the quizzes. So don't worry about that for now. Just follow the track. Just follow the session.
Yep. Thank you, Eric. Exactly. And I also know people very often ask for how long those courses. The whole course duration is 8 weeks, and every workshop is around 2 hours. Okay. Then to chat and to communicate, we use Discord. So bit.ly/Cassandra-workshop. And to validate your week, to confirm your presence and to confirm your homework done, there is a Google Forms link. You will get it very soon. And you answer the questions to confirm what your homework is done already. Good. And then enjoy. In the end of a course, every attendee receives a free voucher to get to pass the certification and become a certified Apache Cassandra developer or certified Apache Cassandra operations administrator. And that's great. So it's a workshop series week 1. And in the beginning, we do some bootstrapping to make you able to do the exercises. We discuss what's the Apache Cassandra, why you may need it, why you will love it, and so on. We discuss how it works and say a little bit of the very high level at the data modeling. But, well, most of a part of a data modeling is next week. So let's start. And in the beginning, I want us to do, I want you to answer some questions. So give me a second.
So you can do this on your laptop or desktop, but preferably try and do it on your phone just so you can keep watching the stream. And so it's just on your phone. It's just menti.com and the code is 454572.
Sorry, it looks like code has changed. At least Menti now shows different code. The code is 526572. Sorry, I don't know why they reset the code, but code is 526572. So we go to menti.com and 526572. And as soon as you are in, please push the thumbs up button. We recommend to simply use your mobile phone and go to menti.com and push the code 526572. And I press thumbs up as well. Okay, I see more and more people joining. Thank you for this interaction. People are asking us questions all the time, especially Eric. But that's great what we can ask you questions. Okay, so I don't want to wait forever. Let us start. And if you are not in, please jump in. Yep. 3 questions to adapt content and our talking points. It makes us able to understand the community and what's most interesting for you. Menti is awfully slow for me. How much experience do you have with Apache Cassandra? Never used it? Less than 1 year? 1 to 3 years? 3-5 years? More than 5 years? Okay.
Okay, so that's good.
Yeah, that's a really good result.
Over 100 so far. That's new, so you're in the perfect place.
Yeah, exactly. If you never used it or you are a beginner, you are very good. That's exactly the place for you to be. So we will explain all the things. And I see there are some people using Cassandra more than 5 years. Well, I guess those are DataStax employees helping us to answer the questions. And well, everyone welcome. We always have content for different kind of experiences. Have you been to any of our workshops before? Okay. You see a lot of newcomers. That's great.
Oh, fantastic.
Yes, perfect.
We always have workshops.
Yeah, we have workshops every Wednesday and now during this course every Thursday as well. So we are very happy to see the returning visitors, returning friends, and new visitors as well. That's lovely. Eh? So many people today. That's amazing.
Fantastic.
Good.
Tell your friends.
Yeah, call your friends. Take a look. One of the most common questions. What's the point with those workshops like am I able to have a recording? People ask all the time. And guys, girls, we don't want to hide anything from you. All of our workshops are being recorded and you can attend them any moment just using the same link as you are using right now. No secrets, just come in anytime. Good. Then, are you attending for personal development or business project reasons? And you can answer both. Personally,
nice.
That's what I'm doing. Okay, looks great. I'm really happy to see so many people. That's incredible. Okay, let's move on. And thank you. We will do other questions later with the real quiz. And let's move on. Come on. Yes, good. So, and to do the exercises, you will need to clone or download our repository at the github.com DataStax Academy Cassandra Workshop series. We can do it in a moment. What I would like to show you actually, oops. So we go to github.com. I will make my screen bigger so you will see everything. DataStax minus Academy. And in the very top, you will see Cassandra Workshop series. That's our place to be for all the workshops of this series. And now we are interested in the week 1. To get all the things available for you, you can clone this repository or you can simply download it. Now, introducing Astra. To do work with the database, we need this database running. So far, no one works with the not running database. So instead of making you install Cassandra, which is not the smallest project in the world, to admit, we offer you to use Cassandra as a service in the cloud. That's astra.datastacks.com. And it's a great thing for you because you don't need to do any operations, install, replicate, maintain. That's all done by DataStax, and we are experts with Apache Cassandra. It provides powerful APIs, REST and GraphQL endpoints, and SQL shell. It's cloud native, so you can run it on Google Compute Platform or AWS. And you have 10 gigabytes free tier available forever as soon as you register. No payments, no credit cards. You just get your free tier database of 10 gigabytes available forever. We will not delete it. Application development with Cassandra is pretty simple because for the operations with the database, like adding data or reading data, we use Cassandra query language. SQL is specially designed to be very similar as SQL, and I guess most of you know SQL already. So all the things like insert into, select from, update table, delete something, it looks exactly the same. Now, be cautious, be aware. SQL designed to be very similar as SQL, and it's the bless and the curse of this tool. Why? Okay, why bless? It's understandable. It's like very similar to SQL. It's easy to learn. So what's the problem then? Big problem is people who know SQL start to think, oh, Cassandra is the same. I can use it right now. Big mistake. Big mistake. Cassandra is different. So please stay attentive. We will explain why and what is different. Developer tools, we have DataStax Studio as a web interface to Cassandra with all of the tasks for you to do. And we have a bunch of great drivers from DataStax and also from the community to work with Cassandra from nearly every language you may imagine. And now, first exercise of the class before we start with the theory. Let's create your own Astra instance. First link we need to use is let me show you. First, what you do, you go to astra.datastacks.com and you need to register and sign up. So you can use you can sign up with a normal email, you can sign in with Google account or with GitHub. In my case, it's much easier because I already logged in, already registered. And now I'm in the Astra control panel. And we are going to create new database. I have one already, so I will not create a new one. And for those who need to create the database, there are credentials. Create your Astra instance. And now notice that's important for you to use the credentials we are giving, because if you specify something on your own, it may not work perfectly with the exercises we ask you to use. So when you create a database, first specify to use free tier, please. It's a free tier, so you don't pay for it. If you specify C10, then we will bill you for that because that's already commercial environment. So please stick to free tier so far. When in the location, you specify which region is closer to you. So it's going to be United States East or Europe whatever is closer to you. The database will be free as long as you use free tier, so you don't pay for it. And then the most important thing, database name. You specify killer video cluster. Key space name. You specify killer video. Database username, KV user, KVU capital. And database password is KV password, KVP big, please notice that. And then you press to launch the database. It will take some time, but don't worry. We will start to work with the database some minutes later. First, we have to discuss some theoretical part of things. So now please go and create your account. Yeah, Eric?
So yeah, so very important thing to point out here is that you need to follow the case, the capitalization. So the key space name has to be in all lowercase. Killer video without an E. And the same goes for the username and password. So the first 3 letters are capital, and then the rest is lowercase. Because if you get this wrong, you won't be able to run the exercises later on.
Yep. So, okay, if you made a mistake, nothing so bad. You can always terminate this free database and create a new one. One often question, if you have attended one of our before workshops, you may already have your database at the free tier created. Then the button create database will be not active. Create free tier database. Nothing is wrong, or you can terminate the previous database and create a new one, or if maybe your database is already having these credentials, killer video cluster, killer video, KV user, KV password, then you can simply reuse that. But in general, I would suggest to terminate the old one because it may have some preloaded data which will conflict with the new exercises.
Right. So for now, I know that people are getting, asking questions about what a key space is and stuff like that. So just get your database launched for now, and we'll talk about. We'll start explaining it, but it's very important that you start launching your database on Astra right now. And some people are asking for the links to the instructions. They're the links that was provided earlier on. So some of the guys are going to repost those links so you can access them. But it's the very same links that was posted right at the very start.
Good. Okay. So I don't want to hold us for too long. If you have created your Astra account, which is pretty quick, create your database using credentials we published. We have shown, and we are ready to go to the most interesting part of this workshop. So I give you 1 more minute to set up. Please be quick. Let's hurry up. We have a lot of interesting coming in. Good. So I hope you are done. If you are not done, then you always can proceed. The main thing for today's workshop for us is to listen us and do exercises, but you always can do exercises later. Your database is already yours and it stays yours forever, so you can do the exercises in any moment. And we have some extra content at the academy.datastacks.com. I will tell you in the end of the workshop. And also, if you're stuck in any moment, Then here is Erick RAMIREZ, the Lord of the Cassandra rings at the community.datastacks.com. So you can always find him, well, and me as well there and ask the questions. But let us move on. If your database is running already, that's great. If your database is being created, that's also very fine because, well, we have very many people creating databases right now. So that may require not only creating of the databases, but also deploying new instances in the cloud because more and more people are using the database. Okay. Now, my favorite part of this workshop, it's more interesting than bootstrapping, Apache Cassandra, why, what, and then. And you know, why is, I believe, the most important question in the software development and IT in general. So let's talk a little bit about why. Apache Cassandra is a NoSQL distributed database. Every word here is very important. You can use a single node Cassandra instance like at your laptop, but usually that's not the point to use the Cassandra, and it hides all the benefits and best sides of the Cassandra cluster. One node installation, depending on your hardware, of course, is usually has capacity up to 4 terabytes, although we usually stack to 1 to 2 terabytes. And some companies, and for some use cases and strategies, prefer to have even less to be able to bootstrap new nodes faster because, well, when your new node is going to have 2-3 terabytes, starting of a new node is obviously going to take some time. And about the capacity, that's pretty clear, but with output, it's really a lot of transactions per second per core, because now it works really lightningly fast. It's one of the most performant databases in the world. And the main use case for Cassandra as it's a distributed database, to have a cluster of the nodes. So you usually don't run Cassandra on a single node as long as it's not your laptop, but you run a cluster. So multiple nodes, and all of them communicate with each other. Cassandra is a masterless system. So, you know, like there is, due to all the events happening in the world and all the situations, a lot of companies now rework their code to get rid of master-slave terminology or things like that. That's not the point for the Cassandra, because Cassandra never had any masters and never had any slaves. Cassandra is a masterless system, and you can easily... And every node has the same responsibilities and duties. And in case anything happens with one node, other nodes will take over and take care of the things what this node was responsible for. So every node is very resilient, but you know, like in the real world, there are no unicorns and not so many rainbows. There are always problems with network and power, and so on and so forth. So failure of some nodes is not a problem in this case. Group of the nodes all together make a data center or ring. We call it a ring. Basically, a ring is a data center. And some nodes in this data center, everyone communicates with each other. One of the best benefits of a Cassandra, what it scales linearly. What does that mean? Cassandra has very low to zero overhead on adding new nodes. If you want more output, if you need more capacity, just add more nodes and that's it. There are many great databases in the world, but most of them suffer of a big issue. Every next added node adds not like the full power and not the full features. There are overhead on adding new nodes. Cassandra scales linearly. The more nodes you add, the more power in your cluster. And that goes like in the plain line. It was a very interesting report by Netflix, which Netflix team did a research and scaled the Cassandra cluster, if I'm not wrong, from 3 nodes to 350 nodes, and they reported a perfect linear scalability. And that's amazing. Now, why Cassandra was created? They have a lot of great databases, like relational databases of past, for example, and they're good in their field. But as soon as you start to work with really big data, you may get to the situation your data doesn't fit on a single server and you want to go with sharding. Sharding on relational databases is hard and painful. And with Cassandra scalability, we simply adding more nodes and data spread it all over those nodes. But how exactly it's scaled? There are two ways to scale, horizontal and vertical. What does that mean? With vertical scaling, you have a medium-sized server, medium power computational power server. You start a new one, big one, much more powerful, much more expensive. You transit data, usually with downtime, and you take down your old server. Your new server is much more powerful and much more expensive. And you still have a single machine, which is still a single point of failure, and failures happening all the time. That's vertical scaling. In Cassandra, for Cassandra, we prefer horizontal scaling. What's horizontal scaling? Horizontal scaling means you not replace an old machine with a more powerful machine. But horizontal scaling means add more nodes. Horizontal scaling requires multiple, less expensive commodity hardware machines. Well, commodity hardware, every company has different budget. So commodity hardware is kind of a little bit flexible definition. For some companies like Apple, Apple is one of the biggest users for Cassandra. Obviously, those commodity hardware aren't really going to be commodity, but still. But one thing to recommend, that's important for us to have even data distribution over the cluster. So we do recommend to have all the machines of the same level, of the same computational power, disk, CPU, cores, and so on. Because if you have machines of a different computational power, RAM memory, and so on, and then Cassandra still tries to replicate data evenly, and you may have some situation when your less powerful nodes will be overloaded, while more powerful nodes will be still idling. So we recommend to use all the nodes of the same state and the same computational power. Now, data is distributed. I've mentioned sharding before. If some of you happen to implement sharding for relational databases, knows how much pain is it and how you should manually shard your data and put it to different servers. It's a really painful and slow process. Cassandra is designed to work with the big data very, very, very fast. And to do it, we have to partition things by default in the very beginning. So, like sharding is a painful process, partitioning is a fully automated native process spreading data over multiple databases. Take a look at the right part of the screen. What we have now is on the left side, Cassandra cluster of 7 nodes, and on the right, we have a table. This table contains information of the population of a city in a country. So every row is a country, city name, amount of people living in this country. So how we would store this data on the traditional database? We just store it all together on a single machine. It works well as long as your data is not so big, or you don't need to have this data everywhere in the world. It will work. Cassandra partitions data, moving it over all of your machines. So, some of the data goes to one node. some to another, some to third, and this way data spreads over the nodes you are having. And what's important for us to understand is that how do we identify partition? You could notice something in the allocation of the data over the nodes, something what unites this kind of data, something what works as a key to the partition. For this table, it's the country name. So cities of the United States go to one node. Cities of the Germany goes to another node, and so on. In this case, when creating this partition, we use it country as a partition key to define those partition and define the data allocation over the cluster. What does that mean? It means what all the rows with the same partition key will go to the same partition, and we will have them stored together. And that's important to understand. We speak mostly about partitioning in the second workshop, but that's important to understand. There is a difference. In the relational database, how do you access your data? You define your database, you define your table, and then you specify some conditions where you can load the data, like select username from users, where user ID equals some user ID. So you specify database, table, and row. In Cassandra, you have one more unit of access, call it partition, and we will cover it very soon. Now, okay, now we are ready to work with big data, because we spread our data over multiple machines, and if you add a lot of data, again, you just add more nodes, and data will be replicated when. Operations guys asking at this point, how happens if I add a new node, I have to manually move my data? No, Cassandra takes care of it for you, and that's great. But that's not enough. Cassandra is well known to be one of the most resilient and fault-tolerant, disaster-tolerant system. How it works? Replication. Replication means we replicate or duplicate the data to have more and more of the same data available, and therefore available at any moment of the time. How the ring works. So ring, you remember, is a data center. In this data center, as you see on the screen, we have 6 nodes. And out of these 6 nodes, every node is responsible for the part of the partitions. So therefore, if you have, like, let's say 60 partitions, let's imagine, and you have 6 nodes, every node will be responsible for circa 10 partition. Well, usually numbers are much bigger, of course. Then the data comes, we calculate which node is responsible for this partition. So in this case, we hashed the partition key, and we receive number 59. Usually those numbers are much longer. And we know which node to store. The node receiving a query is called a coordinator node. Some people start to think of a coordinator node as a master node. That's wrong. Every node is a coordinator node. In this example, data comes to this node number 83, let's say. But if data would come to node number 0 or 17 or whatever, requests still will be executed. So every node is a coordinator node. The node which gets the query is the coordinator node. Coordinator node, well, every node, therefore, is smart. Every node knows schema data allocation, where the data is stored. So in this case, this node is not responsible for this piece of data, but it knows which node is responsible. And therefore, data and query will be redirected to the proper node, which is called a replica node. Remember, coordinator node is every node in the cluster, because every node in the cluster is able to answer your query. But replica node is the node is storing data you are working with. In this case, This replica node is responsible for this partition number 59, so it will handle and store their data. And you see at this example, it's a replication factor 1. So every piece of data is stored in the cluster only one time.
So if we can just slow down a bit, Alex, because I think people are getting confused a little bit.
Of course.
So what the 59 is the hashed representation of the data. So let's use an example of the partition key is the country. And for the country Australia, when it gets hashed into a token value, let's pretend that it hashes into 59.
That's a very good notice. Thank you, Eric. Let's get back to this table. How the partitioning works. Take a look as we have here, for example, Sydney, Australia. In this table, it states it has almost 5 million citizens. Is it correct? Eric?
It's a bit more than that. It's just under 25 million.
Okay. Yeah, a little bit more. So in this case, this column country is the partition key. So how does this token happens to be? There is a hasher or partitioner using so-called murmur-free hashing mechanism. It takes the country name in this case, as we specified this token, as we specified this column to be the partition key. It hashes this value and receives a number, so hashed value of this RU. And let's imagine this number is 59. Usually it's not 59, but 5968, 5968, and so on and so forth. Very long numbers, but to simplify, let's imagine it's 59. Good. Now, you see what happens if this replica node becomes unavailable. Then this piece of data will not be available for us because of a network outage or whatever bad things may happen in the real life. So we go with replication factor 2. And what's replication factor 2? It means what every node is responsible for 2 token ranges. So for 2 different sets of partition, like of me and my neighbor. I'm taking care of my data and the data of my neighbor node. And my neighbor takes care of his data and my data. So we help each other and protect each other in this way. When we have replication factor 2 and data comes, for example, to this node, it becomes a coordinator node. It again knows the data allocation. And then it sends this data to the proper nodes, so to 2 nodes to store this data. Those 2 nodes are replica nodes. And mostly used by Cassandra, replication factor 3. You could guess we have 3 replica nodes, and therefore data will be stored on 3 different nodes. And if anything happens wrong with one of the nodes, data is still available. And that's very important. Due to data replication, in case of node failure, you still can you still can reach your data, read that, or update that. What happens if node is on fire and you can't store your data? Coordinator node doesn't get the confirmation what data was stored, and therefore coordinator node stores a hint, so-called hinted handoff, for the failed node. And as soon as node recovers, this hinted handoff will be sent again to this node, and node will be recovered in fully automated node. So in case anything happens with your server, that's job of a Cassandra to recover it, as long as node was recovered in the grace time period, which is usually about 3 hours. if node was not available for a longer period of time, like for one full day, 24 hours, for example, amount of hints may be too big in the overall cluster, especially for data-intensive application. And if you use Cassandra, it mostly probably means you are using working with a data-intensive application. Very clear. So in this case, I would suggest to decommission this node and bring it back again as a new node. This way, we could avoid some issues. And by default, hinted handoffs stored for 3 hours. Notice, as soon, Eric?
Yeah, so we've got a question that keeps coming up. So why does the purple node own, or why does the data for the token 59 belong to the purple node? And that's because in our example, the purple node owns all the token ranges from 51 to 67. Just like, and so that's why it doesn't belong to the gray node, because the gray node owns everything from 34 to 50.
Exactly. Thank you, Eric. Yes. So imagine you have some data. Okay, countries example maybe not the best, but imagine you have clients in very many different countries and you partition them by country. It's not the best way, and I explain it why next week. Join our data modeling workshop next week. But still, if you partition your users by a country, you therefore, I don't know in how many countries operates your company, but let's imagine in 100. So altogether, you will have 100 partitions. And now let's count. Imagine we have 3 nodes and replication factor 1. Then, how many of the partitions will every node have? 33, 33, 44, because you have 100. Replication factor is 1, and you have 3 nodes. When you have 5 partitions, and replication factor is still 1, every node will have approximately 20 partitions to handle. And imagine now you increase replication factor to 2, and therefore every node will have 40 partitions to handle for itself and for the neighbor, and so on. So I hope you answered the question. What do you think?
Yeah, I think so, yeah.
Good.
And so now I think people have moved on. So what's a hint? So a hint is just a mutation that didn't make it to a replica. So in this example, we've got a replication factor of 3, which means that there's 3 copies of the data that exist in the cluster or in the ring. But because at some point the blue node was down, it was on fire, it was unresponsive for whatever reason. It had a hardware failure or it had a power outage. So it was down. The coordinator node, which in this diagram is the orange node, it was sending a write to that replica. It wasn't available, so it will store that write, which as a hint. It's called a hint when it stores it. And so in the next slide, when the blue node comes back online, it will replay that write, which means that it will send a hint, which is a mutation. A mutation is an insert, a delete, an update. It will send it to the blue node because it's come back online, so that that blue node will have will be consistent just like all the other replicas in the cluster.
Yes, in general, when you start to replicate your data, you own a great power of reliability and resilience and fault tolerance. If node is down, then you still can retrieve your data or update it. That's great, but that also brings some issues to handle, like with great power comes great responsibility. In this case, this responsibility is about to keep data consistent. Like imagine if we would not have hints. What would happen in the case one node is over forever, for whatever reason, doesn't matter. We will have our data and 2 nodes updated and at 1 node not updated. It called it inconsistency because one of your node has then outdated data, something has changed. Your client has bought something, his account, amount of money at his account decreased, but one of your nodes still doesn't know about that. That's a big issue. So as Cassandra is distributed and replicated database, it has very many powerful tools and ways to control the consistency, and we will discuss it in the next slides. But what's important to know, there are multiple defense mechanisms, self-defense mechanisms to protect data from the inconsistency. So hinted handoff is just a first layer of self-defense. Then we have repair on read, and so on and so forth. That's a part of a maintenance course, maintenance workshop, later weeks. Good. And the last and one of the most powerful features, which I really like, is the distribution of the data over the world or over multiple clouds. The trick is, before we discussed a single data center cluster. So, well, that's very fine. You have your cluster. It's deployed in only one and single data center. That's a very common use case. But as you become to be global, as you start to work in Australia, Europe, United States, India, and so on and so forth, then you want your data to be close to the client. Like imagine we have database launched in the Europe, like close to me in Frankfurt, for example, and Eric tries to work with this database and he's in Australia. Do you think he will be happy with response time? I don't think so. So using Cassandra, you may have multiple data centers within the same cluster working with the same data. And your clients from Australia will work with Australian deployment, and your clients from the United States will work with the United States deployment, and all of them will have answers in milliseconds. And that's active replication in the relational world known as master-master active replication. They don't have masters, so I cannot say it's master-master. It's active, global, multi-data center, data replication all over the world. And it brings us some great features. Before we discuss it, fault tolerance. So one node is down, data is still available. Two nodes is down, data is still available. Geographical distribution then makes you disaster tolerant. We have a client, I will call no names, but do you remember this hurricane in the United States, Katrina? I don't remember the name, which wiped out New Orleans. One of our clients had a data center there. Their operation had downtime of 0 seconds, 0 milliseconds, nothing happened because it wasn't the single data center. There are more data centers, and Cassandra driver is very smart. It detects the failed node and retries query to another node. And then basically application didn't notice it failed data center because driver has switched to work with next available data center. And that's great. But not only geographical distribution. We also, Cassandra is platform agnostic, so you can run it everywhere. We all know what there are some issues happen with nearly every of the cloud provider. Using Cassandra, you can work with any of the cloud providers and on-premise deployment, your own, and at the same time. So one of your data centers could be on AWS, one of your data centers can be on Google Compute Platform, and Azure, and your own. That's especially important if you are like me in Europe, for example, with very strict GDPR limitations of European Union, like especially in Germany, or for example, in Russia, it's the same situation. You have to store data of your clients in this country, and there are some more limitations to come. So, and with Cassandra, it's really easy to specify, so I want this data to be stored in this data center and store it only in Europe Central 1 of AWS, for example, or another cloud you may want to use, or your own data center, like highly secured, highly protected data center. And notice, it still will be the same database, and it still will be the same table. So you can specify, it still will be the same key space in it will be different key space, but you may specify your data stored in the particular data center of the world or of the cloud, and that's very convenient. Now, I bet some of you now really worry about the consistency, because as long as you have your data replicated, you're always afraid to get outdated answer. And again, this world is not perfect. You get network outages, you get power outages, and whatever shit may happen usually happens exactly in your cloud. How does Cassandra handle that? How we control consistency? First, we have to say a little bit of word about CAP theorem, or Mark Brewer's theorem. That's applied to the distributed system, any distributed system in the world, and as Cassandra is a distributed system, it applies to Cassandra as well. It means what in the best case scenario, when everything works perfectly, and network is perfect, power supply is perfect, and so on, and everything works, your database can be consistent, available, and partition tolerant at the same time. But in the real world, some problems happening. And to CAP theorem, in the real world, in case of any kind of network issues, power issues, and whatever happens with the servers, only 2 of the 3 points are achievable at the same time. So, consistency, availability, and partition tolerance. What does that mean? Availability means what you get the answer. Partition tolerance means what your database can survive the network partitioning, like when the network is not available, not between client and database, but between one database node and another database node. So-called split brain problem. You may know it if you work it with multi-node deployments for relational databases. And consistency means what you always get the most up-to-date data, and you don't get some outdated information which has been changed, but one of the node may not know about that. By default, Cassandra stays in the world of the availability and partition tolerance. And people call Cassandra AP database, available and partition tolerant. I don't like this definition because technically it's not correct. Cassandra is configurably consistent. And you define which level of consistency, availability you want to have right now. And therefore, you can move Cassandra from AP field to CP field to be fully consistent and partition tolerant, but not fully available. Let me explain you. It's controlled with the consistency levels. And consistency level is defined per query. So when you execute a query, like select something from something, you may specify, I want to have consistency level 1. And notice in this case, we have replication factor 3. So every node is replicated and stored on every data is replicated and stored on 3 different nodes. And we have consistency level 1. Client asks the question to a coordinator node. Coordinator node routes the request to all the replica nodes. And as soon as the fastest node responds, then coordinator node immediately dispatches their confirmation and returns the data to the client. What does that mean? It means what it's the fastest way, potentially fastest way to process the queries. Well, if a network is perfect and all the nodes are working very fast, you will get all the 3 answers at the same, more or less the same moment of time. They're asynchronous, of course, but anyway, you get your data nearly immediately as it reaches the coordinator. So that's the fastest one. But what can go wrong? Imagine fastest node was also the node which lost some data because it was not updated for any reason, like network partitioned at this moment. then you may get outdated data. So usually we recommend to use consistency level quorum. What does that mean, quorum? Quorum means majority of the nodes, like replica nodes. In this case, we have cluster of 6 nodes, and we have replication factor of 3. Freeze for a moment and think how many nodes will organize the quorum. Correct answer is 2, because doesn't matter how many of the nodes we have in a cluster, 6 or 60,000. It still depends on the amount of replica nodes, and replication factor for this data center is 3. And therefore, consistency level quorum, so majority, makes 2 out of the 3 nodes. And then let's see how it works. Query goes to coordinator. Coordinator asks asynchronously all of the nodes about give me the data. And then it waits for 2 acknowledgements, 2 confirmations. 2 nodes return the data. It compares the data, sees the data is the same, like both of the nodes are updated, returns the data to the client. And with the consistency level all, you could guess already what will happen right now. Coordinator node will wait for all the acknowledgements of all of the replica nodes. And it may look like a great idea, but it's not. You may think like, okay, I want my data to be always fully consistent. But what happens then? Let's think. We go to a few slides back and go to our CAP theorem. When you specify consistency level all, what happens with Cassandra? You bring it to the situation consistency and partition tolerant. You move it to the left away from the high availability field. So what does that mean? Very easy. You are not highly available anymore. As soon as any of those 3 nodes are not available due to whatever problem you may have, coordinator node will answer you, desired consistency level is not reachable. I cannot retrieve or update data. Boom. You are highly available, or you are not highly available anymore. Okay, then. So it doesn't sound like the best way. But we still want our data to be available. Like, you know, a lot of banks are using Cassandra, and you definitely don't want your bank statement to be not really consistent. How do we handle that? There is a term called immediate consistency. Immediate consistency means what your data is fully consistent when consistency level of a read plus consistency level of a write is higher than replication factor. Take a look. First way to get the immediate consistency, first way is we write with consistency level all. For the replication factor 3, consistency level all will be equal 3. We inform all nodes, so we write with consistency level all. If all nodes are available and store the data, when write is done and we are good, every node has updated information. And then when we read the data, we can ask any of the nodes and it will be fine because every node has most up-to-date information. In some use cases, it may be a great approach, but in some particular specific use cases.
Right. So like maybe like a messaging app, you know, like when you're sending messages between 2 people, right? Because, you know, if your feed isn't immediately updated, you know, you're not going to lose sleep over it. So that, you know, when you refresh, you know, 1 or 2 seconds later, it will appear there. It's okay.
Yep. So for some use cases, it will work, but there is a better way. Consistency level quorum for replication factor 3 will be 2. If we issue a write request with consistency level quorum and read request with consistency level quorum, it means 2 plus 2 will be equal 4, and 4 is higher than 3, bigger than 3. Therefore, we are already immediate consistent. So take a look at the example. At first, we write data with consistency level quorum. So we absolutely sure what at least 2 nodes out of 3 were updated. Maybe 3, but 2 for sure. And then the read at the consistency level quorum. And where can be 2 situations. Imagine the third node was not updated because of a network outage. The query hasn't reached the third node. Third node stores outdated information. And when we read with the consistency level quorum, there are 2 possible situations. When query goes to the consistency level quorum to the 2 nodes, those were updated. When you immediately get the most up-to-date information. There is a second situation. Then query goes to 1 node which was updated and 1 node which wasn't updated. We use replication factor free consistency level quorum, so we always must ask at least 2 nodes. And when coordinator node sees what data returned, doesn't match. 1 node returned updated value and 1 node returned old value. Then coordinator node handles this situation. It returns you the most up-to-date data and inform outdated node what it must recover, what data was, data mutation was lost, and it called it read, repair on read. During the read, we noticed inconsistency and fixed it. It doesn't change anything for the client, but the data will be fixed. This inconsistency will be fixed. So the suggested way to work with Cassandra is to have immediate consistency and therefore work with quorum. Your use case may be different. And moreover, the same application may work with data of different importance. You don't want your bank account to be inconsistent, but you don't really care if a profile picture of a friend has changed 1 second ago, but opening your whatever network page, you will see his old profile picture because it was updated half second ago, and data is not yet reached one of the nodes you are working with. Like you live in India, your friend lives in Brazil. There can be some delay in the updating data. That's not the bad situation if his profile picture will be updated in half a second. That's not a problem. What does that mean? Again, notice I told you consistency level is configurable per query. Only your application and only you knows how important for you to have immediate consistency for this data. So like for this kind, for financial data, I want to be immediate consistent. Okay, quorum, you are good. You are always consistent. And for some kind of data, you want your database to work at the fastest possible pace, but you are fine if you are getting at some point not the most up-to-date data. There are a lot of use cases like that. And then you can specify like quorum all, for example, quorum 1, quorum to write, 1 to read. It will be the fastest one. But in general, default recommended way is quorum write, quorum read, and you have immediate consistency always. So we get the best of all of the worlds. We can afford losing 1 node and still dispatch data and update data.
And to add to that too, Alex, that's why we recommend that you have a replication factor of 3. Replication factor is the number of copies you have in each of the data center.
Yes.
That's how you achieve the strong consistency.
So in general, it depends on your strategy, but we recommend to have replication factor 3 or 5, because in this case, a quorum will be 2 or 3. For 5 nodes. For example, if you have the 6 node replication factor, if you need to have quorum, you need to have 4 nodes available, because majority means half plus 1. And yeah, so recommended value is 3 or 5. Yeah, but well, free is the main thing. And okay, weaker consistency, as I've explained it before, or eventual consistency, the true eventual consistency. If you write with consistency level 1 and you read with consistency level 1, it may happen what you read not the most up-to-date value. In some use cases, it may be a good choice. Data will be replicated. Consistency level 1 doesn't mean you replicate data to only one of the replicals. No, you still replicate to all. But that's the less reliable way, usually not so much in use.
Right, because so that's a very important point. So just because you're using a consistency level of 1 doesn't mean that the writes only get sent to one replica. The writes will always get sent to all the replicas in the cluster. If you have replicas in other data centers, then it will get sent there as well. Not eventually, it gets sent right at the very same time that the coordinator receives the request.
Now, so we discussed the main features of Cassandra. Cassandra is designed to work very fast with any amounts of big data, the biggest data in the world, while being distributed all over the world if you need that. And therefore, we think of main use cases. Everything what involves huge scalability. Today you have 3 nodes, tomorrow you have 300, after a week you have 3,000. Very fine. Highest scalability, highest output, highest volume. That's very Cassandra use case. And therefore, everything what relates to heavy writes or heavy reads, perfect case. Event streaming, log analytics, Internet of Things, any other time series, Cassandra is perfectly optimized to work as time series database, and that's a very often use case for Cassandra to work with time series data. But also availability. Everyone wants to have data to be available 24/7 to 365 and so on and so forth. 99.99999 available always. Okay, for any kind of mission critical databases, Cassandra is a good choice. No data loss, always on, always available. And we have market data, pricing, inventory, banking, and so on and so forth. Distributed. Well, you see, Cassandra is one of the best ways to have true distribution and active replication in global presence and any kind of workload mobility. For example, one of the users of Cassandra, or to better say DataStax Enterprise, is Uber. When you go to an airport in Paris with Uber, then fly to the United States and go with Uber then to whatever place you need, you still work with the same data and your account is still available, but it will be different databases and it will be DataStax Enterprise. Also, like enterprise version of Apache Cassandra. And also, as talking of distributed, we speak of the compliance and GDPR compliance, so you can specify where exactly to store your data. And that's again banking, tracking, logistics, retail, and any kind of a customer experience where you want your data to be available for customer from the next city, but not from the next continent. And last point, which is very important now, cloud native. Cassandra is cloud native, and it perfectly works in every cloud or in multi-cloud or in hybrid cloud. So you can have the same cluster, different data centers, store it in AWS, Google Compute Platform, and your own data center. And there are a lot of different things, like everything what you can imagine with a cloud. Enterprise data layer all over the world, in every cloud you may want. API layer, and so on and so forth. And now we are going to do some job. So, I told you we are going to work with our data in the astra. Not so big. Hope you downloaded already Cassandra Workshop Series repository as a zip file, or yeah, so you can simply download zip, or you can clone this repository to have everything what you may need. Then in the week 1, getting started with Cassandra, you have a folder, notebooks. Those notebooks are tar files to work with DataStax Studio. So you can choose any of them. If you haven't cloned it yet, in general, no problems. What you need now to do is download them as a raw file. So when you open this page, DataStax Academy, Cassandra Workshop Series, Week 1, Notebooks, DataStax Studio, tar, and working with SQL tar, you will need both, so you can download both at once. You go to this tar file, press the raw button, and it will be downloaded. And therefore, you can do the same for the third notebook. You go to working with SQL, press the raw button, and the third one will be downloaded. Like, that's the easiest way to download the notebooks. Eric?
So we'll have people pinging the links into the different chats on YouTube and Discord. But really, really important, when you're downloading, don't just download the tar file on its own. You have to download using the raw link that Alex was just showing just before then. Because if you don't download the raw link, you won't be able to import it into Studio. You'll get like a corruption message or something like that.
Mm-hmm. Good. Now, my database was parked because I was not using it for some time. Well, I was using it from another account. Doesn't matter. So I need my database to be unparked, and I can show you how to import the database. Unparking. Okay, it will take a moment. I hope your database is created already. Again, if it isn't, no problems. You can do all the exercises later. Maybe it will be even better way to do it later. While we are waiting for the databases to be ready, there are some more things you may need in this folder. So we have also slides, presentation PDF, that's the slides of this week. And all the explanations what we have to do. For the DataStax Studio, we need to upload the notebook 2 into the running instance of DataStax Studio and follow the instructions. And for the exercise working with SQL, we have to download exercise notebook 3 and upload it to your instance of DataStax Studio. How do you get to your instance of DataStax Studio? Okay, my database is unparking at this moment. So, okay, while it's being unparked, what you see now is the web interface of Astra, and you can take a look at yours. We have here very important things like health, to see the diagrams of the state of your database, and SQL console. As I say, to work with Cassandra, we use Cassandra query language. So in the SQL console, you can execute Cassandra query language statements and work with the results. Pretty convenient to go. But obviously, most of us going to work with Cassandra using some drivers directly from applications. And in the summary, as you could see, I have a total storage of 10 gigabytes because I'm using free tier as you, and my database is located in Europe West 1 because, well, I live in Europe West, or, well, more central, but still Europe West 1 is close enough for me. And as it's a free tier, I'm having replication factor 1. So replication factor 1 means that's a free tier So I can do all the exercises I need, but replication factor 1 is for my statements to be, if I do it consistency level 1 or consistency level quorum or consistency level all, it means all the same, still 1. It's parked on my second account. Database is parked already as well. Okay, so I will switch back to the first one. It should be ready in a minute. Okay, so what I suggest us to do then is first we run the second part of the quiz with Menti, and when we get back to this exercise. I hope it's fine because, well, I don't know if I need 1 or 3 more minutes. I don't want to make you wait. So let us move on to the next quiz.
Would this be a good time to take a quick break, or should we do the quiz and then do a quick break?
Or we can do a 2 minutes break indeed. Because yes, I think you are right. So we did already 1 hour and we did already pretty a lot. So let us make a 1 minute pause and join us at menti.com, and we will join you in 1 minute.
Fantastic. So if so that everyone can do a quick toilet break and grab a drink, maybe.
Yeah, definitely.
Yeah, so all the recordings are available on the DataStax Dev channel. You can view them anytime. It's all the workshops that we do are all recorded. They're available at any time from the DataStax Dev's channel on YouTube. And I'm just looking at the posts. A big shout out to Big Craig. How you going? Yeah, so parking on Astra is the same concept as parking any of your cloud instances, whether you're on you're using Google Compute or whether you're using Azure or EC2 instances. If you're not using them, if you park them, you get charged less. So it's the same concept with Astra because it's a cloud database. If you're not using it for whatever reason, you can park it. Question from Hassan, can I submit the homework in 1 or 2 weeks later? You can do the homework anytime you want. It's just that it prepares you for the next session. That's why they're homeworks.
Hi again, I'm back.
Welcome back, Alex.
Yep.
That was a quick break.
Okay, so I see we have a lot of people ready. So let's start with the quiz. To answer the questions, please go to menti.com and use code 526572. And here we go.
And you have to hit the like button.
Yeah.
On Menti.
Thumbs up. Oh, I see more and more and more and more and more people. Perfect. Only 75 avatars are shown. Oh, of course, we have much more. So I see almost 400 players are ready to go. And when we start. Now pay attention. Wrong answer gives 0 points. Correct attention. Correct answer give points. Faster is better, but still important to give correct answers. And we have no results yet in the leaderboard. So.
And just to be clear, right? So if you answer on YouTube or if you answer on Discord, it doesn't count. You have to answer on Menti.
Yep.
You can do it on your, preferably on your phone, but you can do it on your laptop, and you'll win a prize. The leaders will win a prize.
Yep.
Here we go.
In Cassandra, how is data distributed? Using partitions? Data is copied to every node? Using address locators or through the mail? Time is up, and let's see the results. Most of you answered partitions, and that makes we did our job good. Please notice 46 people answered data is copied to every node, and that's not correct. I have a question to you outside of the quiz scope, but now just try to guess. What's the biggest known deployment of a Cassandra databases in the world? Just try to imagine how big is the big. I'll tell you. The biggest known deployment of a Cassandra is used by Apple company, and it consists of more than 175,000 nodes. 175,000, maybe even more already. That's not a single cluster, that's a group of clusters, but the idea is this the size of the Cassandra deployments, but one company. And for Instagram and Netflix, numbers are smaller, but not so much smaller. There's still dozens of thousands of servers. And if you would copy data to every node, can you imagine? That just makes no sense. We copy data to every replica node using partitions. And let's see the results. Who is going to be the first? The fastest one is Piotr Jastrzębski. I'm sorry if I'm reading it wrong. I hope I read it right. Then Guy and Jay. Those are three number one peoples, but competition is really close. Let's move on. How do you scale a Cassandra database? Add faster hardware, increase the scale factor, add more nodes, stack nodes until they reach the desired height. I'm really curious on your answer.
So someone's asking, how do they join the quiz? It's right on the screen. It's menti.com and use the code 526572 to join.
Yep. And the correct answer is add more nodes. Add faster hardware is not the Cassandra way. It's so-called vertical scaling, and we prefer horizontal scaling as more efficient. Increase the scale factor. There is no thing like a scale factor. You may mean replica factor, replication factor, but it's not the main thing to scale the database out to be more efficient. We add more nodes. And well, I will not comment the last option. And leaderboard changes a little bit, but all the leaders answered correctly. Maybe someone was faster. So let's see. Oh, there is a change. Sudharsan Sudarajan, sorry if I pronounced it wrong. I do my best. Is now the fastest one with 1,946 points. Then Skits and Satish And the former leaders lost some time on reading the answers, I guess. Let's move on. There are still more questions to answer.
Not much in it.
Yeah.
Not much in it.
What's the recommended replication factor? 5, 3, 42, 1. Who needs more than one node anyway? Well, I need more than one node. 3, 2, 1. Time is up, and I'm waiting for your answers. Correct. So most of you answered correctly. The recommended replication factor is 3 per data center. In some smaller amount of use cases, it may be 5, but the default recommended factor is 3. And I like guys who answer it 1. Good. So none of the leaders made a mistake, but Sudhar-san and Satish are holding the line, and Piotr Jastrzebski get back to the top 3 of the answers.
Oof.
Yeah, I was worrying for you, man. Now,
Not much in it. There's still a chance.
yeah, a Cassandra database can be deployed on AWS only, any combination of on-premise and cloud provider, only one of the following, or on-premise, or AWS, or Azure, or GCP, or on a live raft in the case of emergency. Well, technically it can. Time is up. So, correct answer is any combination of on-premise and cloud providers at the same time. Cassandra is fully platform agnostic, so you can deploy it in any combination of the data centers, your own and cloud, different cloud providers, all in the same time, and have your data spread all over the nodes on these deployments. And
lots of companies do this.
Yep. That's and only one of the following: on-premise, AWS, Azure, or GCP. I don't know what you mean. Maybe you mean Astra. At this point, for a free tier, when you deploy a free tier, you can specify AWS or GCP, or at least it was able some time ago. But in general, Cassandra, you can run everywhere, and that's the main point. It still works all together. And leaderboard. Okay, still no mistakes at the leaders.
Ooh.
Guys are holding the line, okay? And still a tight competition.
I'm very impressed. I'm very impressed. I think this is just one of those few times when it hasn't changed much.
Yeah, usually people start to make mistake. They're worrying. Okay, then. The CAP theorem states what in a failure scenario with a distributed system, consistency, availability, and partition tolerance are all achieved. Only availability is achieved. Only 2 of the 3 guarantees are achieved. I should buy a no in UCAP. Well, also an option.
Oh, throw into my hand.
Yes.
Here we go.
Oh my God, 153 people got into our trap. Ladies and gentlemen, it was a trap. First answer, consistency, availability, and partition tolerance are all achieved. No, are not achievable altogether. Only 2 out of 3. Correct answer is only 2 of the 3 guarantees are achieved. So let's see at the leaderboard. Someone may got into the trap. No! Amazing.
Oh, wow. Okay.
Yes, that's very good. Nothing changes in the leaderboard in the first 3. And then we have Shruti and Sajiv and Seats and Rahul Pal. And I don't know how to read these. Sorry. And Nitin M and Sagar. Great. And next question. The recommended way to achieve immediate consistency is to use read, write, 1-1, 1-all, quorum with a video chat between coworkers. Well, video chat can help you to achieve consistency in the team maybe, but for the database, there is another recommended way to achieve immediate consistency. Okay, good. Eric, you see, we explained it. Very well.
We're getting somewhere.
Yeah. Read, write.
Paying attention.
Read, write is a quorum. Quorum is the recommended way to achieve immediate consistency. Answer 1, all will reach immediate consistency, but it's not the recommended way. And read, write 1 is the recommended way if you want to achieve weak consistency. But usually that's not what you want. And the leaderboard. Oh, no. Okay, they're holding. Come on. Is there still a competition? Good.
How do they do it?
Yeah. That goes very quick. And, okay, that's too early. We will not explain data modeling for now. Okay. Come on. Yes, perfect. So, I hope my database is ready by now. Okay, it's still
So
unpacking.
while that's loading, so you see the top 3, can the top 3 ping Jack Fryer, please?
Oh, yeah.
Either on Discord or on YouTube. Can you ping, if you're in the top 3, so that's Sudarshan, Satish, and Piotr. Can you ping Jack Fryer, please, so he can he has your details to send you your prize.
Yep. Best way to find Jack Fryer is at our Discord server, or you can write him an email. Okay, Eric, it looks my database is still not ready. Do you think I could use yours so you can simply share your screen?
Absolutely.
Perfect, thank you. Look, sorry, it looks like we lost Eric. Let me make him back. Yes, he got disconnected. Please give me a second to bring Eric back. Hey, Eric. Yep, I'm trying to bring you back. Okay, you are in the screen, and I hope you can share your screen now.
Brilliant.
Yes, perfect. Just give me a moment. Okay, so now we have Eric's screen on the screen. Could you please press Command plus a couple of times so we will have a better view?
There we go.
Yeah, now it looks much better and we can see what's on it. So, Eric, could you explain what we see?
So we've got the Astra dashboard here. So I've got my killer video database, which I've called killer video cluster. It's got the killer video key space here.
For us, the main thing now is to launch Developer Studio. The button to launch Developer Studio, then you have your database page like with Erick's, is Launch Now button on the bottom of the on the left bottom on the screen. And then you press it, you go to the DataStax Studio. So once again, what is a DataStax Studio? Is we can say web interface for Cassandra. There you can do different things like reading our tutorials and executing statements and do your exercises mostly. The main thing we have to do right now is to import a notebook. Could you please show how to do it?
So I'm going to go click on Add a Notebook. And I'm going to choose to upload. So I'm going to click on the Upload tab. I'm going to select the file. Let me.
I guess you have to download them first.
Yeah, let me download it again.
Perfect.
So I'm going to add it. So I've clicked the big plus, I've clicked the add. I'm going to choose the upload. I'm going to select the file now, the file that I downloaded.
And you need downloads. Oh, here we go. Good.
And I'm going to open it. And now it's importing. And there we go.
Yes, now you have a notebook open. And you know what? To save us some time, I will ask you to do these, to finish those exercises as a part of your homework. Because what I want to do is to move on a few next steps in the workshop part. But first thing, Eric, could you please show like first few steps? How do you do first step and how do you execute a command?
Right, so we're going to scroll down here. So for example, I've got this describe key space command here. And I'm going to hit the run by clicking the play button right here. So I'm going to do describe key spaces. And I'm going to hit the run button. And it's running, running, running. And now you should see the result here. So we've got a few system key spaces, but the one that we're interested in is the killer video one. And that's just to show how to do it in Studio.
Yeah, so you see, using Studio is pretty simple. In the SQL cells, you type your queries and you run them, and you see some results out of the in the field bottom of the execution field. And your job will be to do notebook 2 and notebook 3. First exercise, don't ask me for notebook 1, people ask all the time. The point is, the first exercise is to create the Astra account and Astra database. That's why we don't have a specific notebook for that. Okay, Eric, so I think I'm ready to go on. So I'm switching from your screen to my screen. Hope you are fine with that.
Yep, go ahead.
Good. Just a second. Good. So it's again my screen back. So now, as I said, a Cassandra query language is designed to be very similar to SQL to make it easier for you to learn. So the statements you have in SQL will be very similar to statements you have in SQL. In this case, for example, we see the create table statement. We create table in key space users, with users by city name for this table, with city field row type text, column, sorry, last name column type text, first name column type text, address again text, and email again text. That's a pretty textive table. And downwards, we define primary key for this table. Primary key consists of two parts. Partition key, so the first part, in this case, just city, and last and first name as a clustering columns. There are two entities for us to discuss, partition key and primary key. Partition key is needed to define the partitions. Do you remember in the very beginning, we used country to define the partitions, how data will be grouped and stored on the servers. And in this example, in the field users by city, we use city to partition the users. And that's pretty obvious what city name will be based for the partition. The main feature for the partition is to define a partition key is to define the partitions. And now the main feature of the primary key, which consists of partition key and clustering columns. So in this case, city, last name and first name, is to ensure uniqueness and make us able to reach the data to change it or read that. And this table has an issue, and I want you to make a little think of it and try to find this issue. So you can try to see, you can try to find a problem and write about it in YouTube or Discord. I'm very curious who will be the one to first to identify the issue. No, parentheses is not the problem. That's not, oh man. Yes, but I don't mean parentheses. Thank you. Yes, thank you. So first answer I've noticed it, at least to be correct, is J12 at Discord. It's not going to be unique. And the correct answer is yes. In this case, the primary key will not be unique. City, last name, and first name together build a primary key, but this primary key cannot be unique, will not be unique, because imagine how many of John Smiths you have in New York, or I don't know, Ivan Ivanov in Moscow. So that's like a very dangerous design. Think of it. Primary key is to ensure uniqueness and make you able to reach the data. And partition key is to group the data. Oops. Oops. Okay, I missed a slide. Let's get back to it. And create a key space in SQL. What is a key space? It's like a schema in relational databases. Key space groups tables. So you have first the cluster. In cluster, you have database. In database, you have key space. And in key space, you have tables. So here we see how do we create key space. In this case, we create key space users, which is pretty simple. Yes, we create key space called users, and then we have to define some options for this key space. There are very many options to define, but in this case, we speak only about the replication. That's the option you must define, otherwise you cannot create a key space. First one is class of replication strategy. And there are two classes, simple strategy and network topology strategy. It's really easy to distinguish. Simple strategy is good for your laptop and bad for anything else. And network topology strategy is what you usually use on staging or in production. It's a network-aware topology strategy. So Cassandra is a very smart distributed system. It knows your cluster allocation. It knows your servers. Well, you specify with snitch or with a configuration file. There are multiple ways depending on your deployment. We cover it in the maintenance and operations workshop. Now you need to know what with network topology strategy, Cassandra will consider your data centers and server racks while deploying your data on multiple machines. Like, for example, if you have one single data center and 3 server racks, it will put, and replication factor 3, it will put copy of the data into the first, second, and third racks automatically, and you don't have to care about that. Why? Because servers within the same rack tend to fail together, like power outage for the server rack. Whole rack is down. If you replicate your data to only the servers within the same server rack, it may have higher chance to be down the whole rack together with all servers within. Then you put your data into multiple racks when it has higher reliability and resilience. So network topology strategies must have on the real production deployments. And then downwards, right. Yep, Eric?
I was just going to say, Alex, so there's a constant repeating questions about what the key space is. So I just wanted to point out that a key space is just a collection of tables. It's a way of grouping your tables. For lack of a better term, it's a database instance in the relational world. There's nothing special about a key space. You can have multiple key spaces in a cluster. Say you had a multi-tenant application where, you know, let's say you had multiple customers. You had customer X, customer Y, and customer Z. Then what you'd try and do is you'd create a different key space for each of those customers, so that their tables are not shared across different key spaces. It's a way of grouping. It's a way of isolating. It's nothing special about a key space.
Yes, consider key space as a group of tables with the same replication class and the same replication factor. Right. And in the downwards, we see data center 1, 3. What does that mean? Data center 1 is just the name of the data center, and 3 is the replication factor we specify. So if you are going to have multiple data centers for this key space, you specify which data centers with key space will be allocated, and how many replicas of data you are going to have in those particular data centers. Notice, you may have one huge, very huge cluster, Cassandra cluster, all over the world with a dozen of data centers. But for whatever your reason is, you may want to have a set of tables available only at the 2 of the data centers. Doesn't matter why, that's a part of your strategy. For this data, you don't want to put it everywhere. When you specify for this case space, data center 1, like let's say AWS East US West 1, like an availability zone, as a data center of AWS you are using, let's imagine, you want to have replication factor 3. And then let's say you are using Google Compute Platform and you want to have replication factor 5. So you specify both of those data centers here and specify the desired replication factor. Any more questions so far? Okay, good. So a little bit of read and write path. So to understand when and how to use Cassandra, you need to understand some undercover things of how it works, and we want to explain it to you. Write path. Then the query reaches the node. Like in this case, we're inserting information about a user from Houston, Texas. This information goes to RAM, to the memory, and on disk to commit log. Commit log is a file operation, but it's just a simple write ahead log. So it's a very, very fast operation. Write what appends only, and there is never searches or never anything. So it's still very fast. As soon as data is delivered to commit log, node returns acknowledgement. Okay, I got your data. Let's think why we need both. Memtable is to work with the real data, and commit log has 2 main duties. First, it's for the reliability. Imagine at this step, node lost power, and all the memory is wiped out. Random access memory is wiped out. RAM is empty. But we still have commit log. As soon as node starts back, commit log will be replayed and data will be reloaded into the memory. So that's for reliability. Second feature is change data capture. That's a very powerful feature, but I will not speak about it at this workshop. So join our next workshop to learn some more about the magic of change data capture. Then next data comes and it goes the same way. It goes to memory and commit log, and to memory and commit log, and to memory and commit log. And now I want you to be, I want you to answer a question. Notice we have the same data in the memory and on the commit log, but it's sorted in the different order. And my question is, why? Answer is, commit log is a simple append-only operation thing needed mostly for just to recover if the node was rebooted, for example, during those operations. But in the memory, it looks different. There is something the way how this data was sorted. And you may notice it's sorted by the city name. Why? Take a look. When we define create table users by city, we specify city is a partition key in this case, and clustering columns as last name and first name. Clustering columns are a way to pre-sort your data. So they are not only to ensure uniqueness of the primary key, yes, of course, to ensure uniqueness, but also they are to ensure the sorting order. It's really cool what you can specify as a field for sort order in your primary key, and then you start to work with real data. Your data will be sorted already on insert in memory, because sorting in memory is a very cheap operation. And then you load the data, it's sorted already, and you don't need to waste time on sorting while doing read operation. That's one of the points people say Cassandra is very well read optimized. Well, it's also well optimized for write, but this ability to press sort the things before really fetching them, before you even ask for when they are sorted already in the row you prefer, that's pretty powerful thing. Good. And then we have enough data in the memory and we want to flush it. It happens based on multiple conditions. So it may depend on the state of your RAM or the time, or you may initiate flush manually. There are very many situations when flush can be executed. What happens then? Mem table, as pre-sorted already, goes to disk as an SS table. SS table means sorted string table. At this point, we don't need mem table anymore because it's well flushed and we have it on disk. And also, we don't need commit log because we have data persisted. Commit log is gone at this point too. Memory is persisted as an SS table. An SS table is immutable. Why? Cassandra is very well optimized to be very highly performant. And any kind on disk operation like search and change disk is very expensive. It takes a lot of time. And Cassandra is designed to be very fast with any amounts of data you have all over the world. So SS tables are immutable. When we will have new mutations, we will have a second SS table. And then once per 10 days usually happens a compaction. Compaction will merge these SS tables and delete redundant or obsolete mutations. So SS table is basically a log of mutations. Good. So read path.
So can we just go back?
Sure.
If we can just go back one step again, Alex. So
yep.
Just to clarify, so if we scroll back to 2 slides, actually, we'll just stop here for a second. So, so the commit log, so just to reiterate, the reason it's not sorted is because it's a log file. So think of it like being a web server log. You're just constantly appending to the end of the log. That's what makes Cassandra really, really fast when it comes to write, because there are no disk seeks. It's just constantly adding to the end of the commit log as far as persisting to disk is. So the data is in the mem table, and we also append, we make it persistent by saving it to the end of a commit log. There were questions around, you know, how do we do rollbacks? Well, there isn't a rollback because the replicas, based on the consistency level that you set for your writes, a certain number of nodes. So for example, for a quorum of 3 replicas, for a quorum of a replication factor of 3, two replicas have to acknowledge the write. And if the 2 nodes don't acknowledge the write, then the write didn't happen. The driver will get a message to say it wasn't successful. So there's really nothing to roll back there. And another question that came through was that, so what happens when you lose the mem table? Well, that's why they get persisted to disk using the commit log. And so when the mem tables eventually then get flushed to disk into an SS table, we no longer need the commit log segment for that particular mem table. And so it gets the commit log either gets recycled for reuse, or it just gets deleted because we don't need it anymore because the mem table has been flushed to the SS table. That's what we're showing in this slide.
Yep. Thank you, Eric. Yeah, that's an important, that's the important thing to add. Good. So let's move on. Now, read path, we explained how write path and how fast is your data stored. Now, read path. In reading data, we have 2 situations. We read data from mem table or we read data from SS table. With mem table, it's very easy because, well, data is in the memory, so we are able to dispatch the response in milliseconds. That's very easy to do when you have your data in memory. First, our job is to identify the partition, so group of rows stored together. With memtable, again, all the memtables are in memory, so it's not a big deal. We go for a memtable and they dispatch it. Reading the SS table is a bit harder because it's a disk file and it can be a pretty big file. Usually it's kind of very noticeable file. SS table holds ordered partitions. And that's important for us to be able to retrieve the partition as soon as possible. To do it first, we use an optimization called partition index. And for those who have experienced the like file allocation tables and file systems, it looks very familiar. Because, well, it is. Partition index is basically a file allocation table. It says the offset of the partition position in the SS table. So SS file, sorted string table. So we see what partition we are looking for. ID 58 is stored with a byte offset 7000 something. And then we immediately know where to read. And the reading from the file, if we don't perform any search operations, is very fast. The problem is, usually SS table look like that. And then, to simplify it, we have an index of an index called partition summary. To read it even faster, we first go to the partition summary with our token 58, get the byte offset of a partition index, get the partition index, get the byte offset by this token, and again know where to read. So you see a reading of data when you have petabytes of data, like some companies working with Cassandra handle dozens petabytes. That requires some optimizations for you to be able to dispatch this data within milliseconds, even if you have like petabytes and petabytes of the data. And of course, some of you who tend for the optimization would guess there is a very good place for cache. And of course, there is a key cache stored in RAM, so you get your byte offset immediately without searching for partition summary and partition index. There is
if it's cached.
Yeah, if it's cached, of course, but as long as you first query for this partition, this information will be stored in key cache. One more interesting optimization is the so-called Bloom filter. Bloom filter allows you to fetch the data to identify if SS table is here or not using previous operations on this node. That's a funny thing. It never says yes, but it may say if node partition is not here, or maybe SS table, sorry, or maybe SS table is here. So that's pretty funny optimization to optimize even better the way to reach proper SS tables in partitions. If partition is SS table, the Bloom filter may help optimizing the time to reach the proper partition. So the main part of today.
Just quickly, Alex, before you move on. Yep. So because there's a lot of questions about it. So an SS table is the equivalent of, say, a .dbf file in Oracle. Mm-hmm. So in Cassandra, there's SS table files that have a .db extension on disk. That's what they are. SS tables are database files.
Good, thank you. Okay, so we are a little bit out of time. So let's move on. What's next? First thing, finish notebooks if you are not done. Mostly probably you are not done. So Eric shown you how to upload the notebooks to your Astra instance. And there are only 2 notebooks. And first of them is very simple. First notebook is about the studio. That's the studio. Here you type the commands. Here you push the button to execute that. Here you watch for the results. Here is the schema. You can watch your database schema. That's it. So it should take I bet like 5, maximum 10 minutes for you. Second notebook, notebook number 3, exercise number 3 is working with SQL. That's already more interesting. So you're going to work with key spaces and you are going to fetch some data and you are going to insert and read some data in your tables. First homework, finish notebooks. Second homework, please provide feedback to Astra team with the form. Astra is a fresh service. It was launched recently. And we need your feedback to say like what works good for you, what was not good for you, why you are happy, why you are unhappy, and what we can do to make it better. Thank you. Third one, create accounts at the academy.datastacks.com and the community.datastacks.com. You will need them both. Community to ask questions and academy to get the courses. Now, very important course now is DS201 at the academy. It's a free course. And you don't have to do exercises, important. With exercises, it will be a long one, and they're kind of included in what we are doing with the notebooks. But you definitely need to watch the videos of DS201 course at the academy.datastacks.com and do a quiz. Quiz is a very short one and simple one. And complete exercise of the week. There are 3 questions in the form specified on the screen, and these links, all of those links are also available at the GitHub /DataStacks Academy /Cassandra Workshop series. You've used it today. Resources for you may need to have to use to learn. The main point is the academy.datastacks.com, but we also have a lot of great content at the datastacks.com/dev. /dev is the new home for all the developers using Cassandra and DataStacks Enterprise. Ask and share. Join Erick at the community.datastacks.com to ask and answer questions, earn your badges, and so on. That's a great place to ask questions, and on multiple languages even. Follow us.
And Bettina and everyone else in the community.
Yeah. Follow us at YouTube, Twitter, and Twitch. Subscribe to this channel. Next event will happen again at the YouTube next week. So see you next Wednesday. We will speak about data model. That's a very, very important exercise and course to prepare for the best of the world, highest performant applications working with any tremendous amounts of data, still within just milliseconds, microseconds, and so on. And materials for this workshop series are available at github.com, DataStacks Academy, Cassandra Workshop Series.
So Jack has posted the links to the materials and the homework in YouTube and Discord. So have a look through that. So everything you need, all the materials that we've talked about, all the URLs, all the stuff in the homework is all in that one link that Jack has posted on YouTube and Discord.
Yes, perfect. And the course you need to take is DS201 Foundations of Apache Cassandra. That's mostly the things we discussed today, but a bit better explained because this course takes some time. And it's free. You don't have to pay for anything. You just get this course. And we just done with getting started with Cassandra. Our next workshop will be designing efficient data model for highly performant big data applications. And then 2 weeks later, application development part 1, application development part 2. And in the end, you will be perfectly ready to pass the exam. We give you voucher to pass the exam for free. Usually it costs almost $400. Now for you, it's free as you attend this workshop series. And you can be a certified specialist very soon. Next Wednesday, course at the for North America and Latin America, so it may be not the best time for you. I mean, it's like 5 p.m. BST, but that's 9:30 p.m. India standard time, so it may be late. And second list, every Thursday, the same is available on the better time zone for you. Well, maybe better. I don't know your time zone. And the second part is said that's going to be maintenance and operations for the Cassandra cluster, and also tuning and evaluating your data model. And we have few last words for you for Mentium. Where is my Mentium? Yes.
So while you're loading that, the recording is the same URL. I know people keep asking that. It's the same URL that you're streaming now on YouTube. And if you forget, it's just youtube.com/datastacksdevs. DEVS.
Okay, just a second. Okay, so let's start. How likely is that what you would recommend this event to a friend or colleague? To answer questions, please go to menti.com and use the code 526572. I repeat, 526572. Please answer, that's important to us to see. Thank you. You see, Eric, that's a very positive response. And really hundreds of people answering like that.
Very nice.
Yeah.
Thank you.
Thank you so much. Thank you for attending the event. We are happy what you are happy. And we do hope to see you next week, of course. Now, how long do you think should those workshops last? So 2 hours, 90 minutes, 1 hour, 3 hour, until my eyes bleed. That's the correct answer. Let's take it full day, 24 hours marathon. Good. So you see, most of the people thinking 90 minutes to 2 hours. We are a little bit out of time for today. I'm sorry. Hope for next week we will be more on time. If you cannot attend this workshop fully and had to quit at some point, well, mostly probably you don't hear me now then already, or you will not be able to attend the next workshop, no worries, you always can watch the video using the same link, and you can ask your questions at the community.datastacks.com or at our Discord server. Okay, I see your answers. Thank you very much. 90 minutes to 2 hours. Good. Then, how easy was it to get help during the workshop? I can say now we have hundreds of people, so it's hard to answer all of the questions. I'm sorry if they haven't answered your question during the workshop in the YouTube, Discord, or live, but don't worry, we're still here to help even after the workshop. So Discord server or community.datastacks.com. Good. So I see most of the people are satisfied with easiness. Not all. If you are not happy, I'm sorry. Yeah, there is really a lot of people. So let's keep talking at the Discord and community.datastacks.com. And last one, how did you hear about this event? So how got you informed what we are doing this workshop series? Okay, mostly Eventbrite, direct email, Meetup, LinkedIn, and DataStax Academy. Great. Good. Thank you so much for answering the questions. It really helps us. And thank you. Subscribe to us at YouTube, subscribe to us at Twitter, Twitch, and so on. And we see you next week. And thank you so much for the participation. Thank you, Eric. Without you, it would be much harder.
Thanks, Alex.
Okay, and I think we are done for today. So thank you so much for being with us. Do your homework, make one step ahead to be a certified Apache Cassandra engineer. Those are in high demand all over the world. And see you next week. Have fun, and thank you for being with us.
Grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats. Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats. Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats. Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her.